A very good evening to the professor. This is my personal timetable. Sir, in this week, I have the main three things in my priority list. First one is to get the capacitance results in a good way and simultaneously also writing a draft paper as per the research roadmap. And then second one is the corona biosensor research. I have started to measurement the corona research, and also we also got the good result as well. So me and the Prashant just finish all the lab work and focusing on the writing paper, and hopefully in this month we will deliver you the draft, and also the Prashant also give it to you the research roadmap. So according to the roadmap, we will deliver you a draft paper and submit it into the journal. And the third one is the AAO biosensor research. So we have already buy the AAO through online payment, and we'll wait for the AO membrane, and then we put on the substrate, and then we start the experiment with a fresh AO substrate. So these are the three basic things that I have given put in my the priority list. So first is the current status of my PSA paper. So the status is being changed now. Is now status is under review, and hopefully in this month we will get the response from the journal, positive response. And if it is not getting a result in this week, any kind of result, any kind of mail from the journal, then I will send an email to the journal to knowing about the status and the current position, current situation of our paper. So this is the research plan that we followed in the urine PSA biosensor, the updated one as per your comment and suggestion. So we skip the two methods, and also we focus on the step by step progress. So first of all, we use D5 chip here to clean with the piranha and the washing with the DI, then all graphene oxide solution, immobilization on the surface, and the skin coating EDC NHS, and wait for the 1 hour calibration curves kind of, and the immobilization of antibody on the surface. And then afterwards we use this antibody, and then according to the antibody we have defined the five different kind of concentration of antigen put on the antibody. So we have three kind of antibodies. First is 1H12, second one is 5A6, and third one is AB2200. So we define that our 1H12 is more efficient, more actively participated on our chip. So we go with the 1H12, and rest of the two antibody we have skipped this thing and to deal with the antigen. So this is my current PSA capacitance result. So as per your comment, so I have tried three times in this week, and we defined that now we got the better result than the previous one. So now we have just five chip, and it's a bare, and it's a graphene oxide. So there is no as such big difference between them. But now with the EDC and NHS, so last time the value become very different between a difference in each value in each chip. So now we got the less difference, or like the um, considering the value for this step, and then after that, if after that, when we got this, then I move to the antibody step. So in the case of antibody, we also got the this results. It's now less difference between them, but I have to be think about this more and more accurate and more good results. So in this week I have to be repeat one more time as well, and then I have to be, yeah, I will give you the capacitance results. So this is the schematic that is already I have shown to you in the last meeting. So it's a basic is fabrication step that we followed. It's a 3D figure drawn by the Jaya and me with the some giving the comments and the direction as well. So this is the AFM picture that I compiled together, the better pixel pack, better resolution for the paper. So it's the bare one, and the second one is the graphene oxide, third one is antibody, and the fourth one is antigen. So these are the four different AFM features that I compiled together for the implement in the paper. So this is the FTIR. It's basically at this result I have already shown to you, and this one is also I have to be present or have to put in the paper as well. So this is the SEM figure results. This one is the Bayer that I have put as a inset figure, and then it's a graphene oxide, and here is the graphene EDC NHS, and the antibody and antigen. So this is the final picture for the cross section as a cross sectional view. So here I have mentioned only three different kind of cross sectional view. First one is BSA, and the second one is NTPSA, and the third one is antigen. So the fourth one is the basic FTIR results that we put in the paper, and this one is the another antibody um, FTIR figure up to the antigen level, and this is the raw figures that I have shown here in the PPT, and it's up to the antigen, and this is the raw figure of the SEM, and this one is the with antibody, and this one is the without with antibody and antigen. It's a cross-sectional view, so I just skip this one. And also I have already shown to you the this contact angle measurement of each cases, and these are the things that I have put in the 3D figure and making this graphene sheet using a different kind of software, online systems and all. And so this is the figure that I have keeping in mind. So the first is the 3D with the chip, and also mention here the figures that is related to the beside this chip, and then also in this column I will make the chemical view of the each step, so it's more clear and more defined that our work, and it's we can put this figure as a graphical abstract or a graphical paper graphical overview. So this is my paper writing plan is already on the way, and hopefully I will give you in this month uh, with all the datas, with all the figures, with all the contents, and like 80% paper will be done in this month. This is my research roadmap for the writing paper. The first three is already done, but I am working on the first three is done, And the result and discussion, I'm working on it, and the data optimization, it will be completed the 25th of October, but 80% I will give it to you in this month. So this is my achievements, and this from the starting till now. Thank you, sir.